Hello everyone, welcome to today's tutorial video. This time we will learn how to visualize nonlinear function in Python. Let's take a look at one example. We're going to visualize this function, z equal to a certain nonlinear combination between x and y. And if you visualize this function, you can have this result. Before I show you how to visualize this function, I want to share with you the logic behind this function visualization. So first of all, you need to prepare some data for x dimension and y dimension, because this function occupies three different dimensions: x dimension, y dimension, and z dimension, right? So you need to prepare some data for x and y. After you've done that, you're going to define z, because you're going to compose x and y into 2D surface. And in this case, it is helpful to define the z function. Once you have the function defined and the data ready, then you're going to set up 3D space in Python. And this is the space we're going to put everything in here, right? And the last step is when you set up the 3D space and you have a data ready, function ready, and you just bring everything together. Okay, so I'm going to stop share the slides here, and let's go back to the Colab and practice how to do such visualization. Okay, so first of all, you need two libraries. We're going to need matplotlib and NumPy. And the first step is to prepare some data. So let's prepare data for x and y dimension. So let's do this. We're going to define x. This is just for the some data for x dimension, right? So we're going to do this. We're going to use NumPy length space. And this will help you to generate some data points between certain interval. So let's say we're going to generate some data between -1 to 5, and we may need 10 data points. So this is for the x dimension, and similarly we're going to do y dimension. Length space, again, we're going to use -1 to 5, and we're going to need 10 data points. Okay, so this is the x dimension and the y dimensions data. And the next step is to compose x and y into 2D surface, and then we're going to define the z function. So in order to do that, we're going to need the capitalized x and the capitalized y. So this will help you to compose x and y together, and that equal to NumPy mesh grade. And we talked about that in the last lecture. It is the same logic. Every time you want to visualize the function that occupies 3D space, you're going to do the same logic. We're going to put x and y into 2D surface and then define z. Okay, we're going to just put small x and a small y in here. And with this capitalized x and y, you can define z. And this time, z is also capitalized. So z is a function that we showed in the previous lecture. So it is a cosine function. We're going to need a NumPy cosine function. And in this function, it is the x squared. So this is x squared plus y squared. Remember, in this function, we're going to need the capitalized x and the capitalized y. Okay, and then we take the square root. So outside of this, we're going to type NumPy square root and parentheses. Okay, so this is our target function. Okay, now we have the function ready and the data ready. Let's set up 3D space. So we can define figure, and figure equal to plt dot figure. And this is how you define how large your visualization would be. figure size, let's say we're gonna use 8 by 6, and then we're gonna use x, and x equal to fig add subplot, and we talked about that function multiple times in the previous video. And because of that is 3D dimensional space, we need a projection equal to 3D. Okay, and now this is how you set up the 3D space. And the last step is to bring everything together. Okay, so we're gonna use x. This time this function is very important, plot surface, because this function occupies 3-dimensional and you want to visualize the entire surface, nonlinear surface, nonlinear style. So we're going to give that x dimension, y dimension, and z dimension. And if you want to put some sequential color, you can use this C map. And this will give you some color story of that function. Let's use cool. And then we're going to use plot.show. Okay, so let's run this cell. Okay, so this is how you visualize the nonlinear function in 3D dimensional space by using Python. And I hope you enjoyed this video, and I will see you next time.